Hi all, today I am here to discuss about heuristic search, hill climbing technique and dynamic programming. Heuristic search is a type of algorithm used in artificial intelligence to find solutions to problems, especially complex ones. It doesn't guarantee finding the absolute best solution, but aims to find a pretty good one efficiently. The main goal of heuristic search is to find acceptable solutions in a reasonable amount of time, especially for complex problems where exact solutions are not feasible due to large size of the search space. That is, heuristic search is a technique used to solve a problem quickly. Many of the problems fall within the artificial intelligence are too complex to be solved by directly. To overcome this problem, we use heuristic search method. Heuristic tries to optimize a problem using heuristic function. Heuristic function is a function that is used to estimate the cost from a given state to the goal state. The effectiveness of a heuristic search largely depends on the quality of the heuristic function used. That is, heuristic function is used to find the search process in the most profitable path among all that are available. It estimates the minimum cost from the initial state to the goal state. Let's see how it works. Search space. Imagine all the possible solutions to your problem as a vast landscape. This is called search space. Heuristics. A heuristic is like a rule of thumb or an informed guess that helps navigate the search space. It estimates how good a particular solution is likely to be, guiding the search towards the promising area. Finding the solutions. The search algorithm explores the search space using the heuristics to choose which path to explore first. It prioritizes options that seem closer to the best solution based on the heuristics estimate. There are different types of heuristic search algorithms. Some of them are hill climbing, A search star, greedy best first search, genetic algorithms, etc. Here are some common applications of heuristic search: pathfinding and route planning, game planning, traveling salesman problem, scheduling and timetabling. These are just a few examples. Heuristic search is being applied in many other areas. Here are some benefits of heuristic search. Faster than brute force. It avoids exploring unnecessary part of the search space, saving time and resource. Good for complex problems. For problems with massive search space, brute force search became impractical. Heuristic search offers a practical way to find a good solutions. There are some drawbacks also. They are not guaranteed optimal. The solutions might not be the absolute best depending upon the quality of the heuristics. Designing a good heuristics. A good heuristics is crucial for the success of the search. Designing an effective heuristics can be challenging. That is, heuristic search may not give best optimal solution always. Hill climbing. Hill climbing is a fundamental technique used in heuristic search for optimization problem. It belongs to the family of local self algorithm, which means it explores the search space by iteratively moving from one state to the neighboring state. That improves upon the current state according to an evaluation function, which is also known as heuristic function. Hill climbing is a variant of generate and test technique. It uses greedy approach and there is no backtracking. We can look how hill climbing works. There are mainly 5 steps. First is initialization. Hill climbing starts with an initial solution that is generated randomly or based on some heuristic method. Next, evaluation. The algorithm evaluates the current solution using an objective function or heuristic function. This function provides a measure of how good the solution is. The goal is typically to maximize or minimize this function, depending on whether the problem is a maximization or minimization problem. Next is neighbor generation. Hill climbing generates neighboring solutions by making small modifications to the current solution. This modification can include changes like altering a single variable, swapping two values, or any other operation for the specific problem domain. Selection of the next stage. Among the generated neighboring solutions, hill climbing selects the one that optimizes the objective function the most. It means it selects the solution that is considered the best among the current neighbor based on the evaluation function. The last step is iteration. The step 4 and 2 are repeated iteratively until one of the following conditions is met. Conditions are: a solution is found that satisfies the problem's requirements or constraints. No better neighboring solution can be found, and the algorithm terminates. Hill climbing are classified into two. They are simple hill climbing and steepest ascent hill climbing. Hill climbing faces several issues. The main issues that faced by hill climbing are local maximum problem, plateau, and ridge. Local maximum problem. The algorithm can get stuck in the local maximum, which is not the global maximum. That is, local maximum is a state better than all its neighboring, but not the better than some other state. That is, we can see in the figure that there is a local maximum state, but the figure itself contains another state which is better than the local maximum. Next is plateau. Flat surface of the search space where neighboring solutions have the same value. Here in the figure we can see the neighbors have the same value. It is a flat area of the search space in which the whole set of neighbor states have the same value, so it is very difficult to find the best. Next is ridge. It is a special kind of local maximum. It has an area which is higher than its surroundings area, but itself has a slope and cannot be reached in a single move. We can overcome these issues by random restarts and stimulated annealing. The next topic is dynamic programming. Dynamic programming is a powerful technique that is used in computer science and operation research to solve problems by breaking them down into simpler subproblems and solving each subproblem just once, storing its solution for future reference. Works best for problems with optimal substructure, meaning an optimal solutions to the overall problem can be constructed from the optimal solution to its subproblems. That is, a problem is divided into subproblems and we solve all possible small problems and then combine them to obtain the solution of the bigger problems. If there are overlapping among these subproblems, then the solutions to these subproblems can be saved for future reference. In this way, efficiency of the CPU can be enhanced. This method of solving a solution is referred to as dynamic programming. This is particularly helpful when the number of copying subproblems is exponentially large. When combined with heuristic search in artificial intelligence, dynamic programming can greatly enhance efficiency and effectiveness. Dynamic programming helps heuristic search. In building heuristics, dynamic programming can be used to solve a simplified version of the original problem with the same structure. Optimal subproblem solutions. These simplified problems might have a smaller search space, allowing dynamic programming to find the optimal solutions for all subproblems. Heuristic estimation. The cost to reach the goal state in the simplified problem can be used as a heuristic estimate for the original problem. Benefits of using dynamic programming for heuristics are improved efficiency and more informed research. Improved efficiency. The pre-computed heuristic estimate can significantly reduce the search space explored by the main heuristic search algorithm. More informed research. The heuristic guidance becomes more accurate because it's based on optimal solutions to subproblems. Thank you.